All right, we're going to do a twist on this experiment here. I'm going to take the two plates. Now I'm going to got some water in this cup. I'm going to add some soap to it. Make it all soap sudsy. All right, sudsy water. I'm going to take my plates here. I'm going to dry them off. There's my pant leg, which is probably not the greatest thing in the world, but it's only water. Put some soapy water on here. Get it all soapy. All right, soapy water. 2 plates, make a sandwich, and release it. What's going to happen? Stick. Right? Sticks a little bit, but definitely is losing. It's losing its suction. I mean, there's some suction there. Let me get it soapier. Soapy. Try to make it stick with the soapy water. It's sticking. Not so good. So the soap kind of takes something away from it. Doesn't make it stick quite as well. So we got to figure that part out next. All right. Third experiment. Oh, where did I lay it? Here it is. Got a Petri dish. And I want to adjust my camera so you can see it a lot better and a lot closer. The Petri dish, where is it? There it is. Okay. Take the Petri dish, put some water in it, if I can reach it. Fill it up with water. Then, this is tough to do. It might not work the first time, so I might have to try it again. I take a paper clip and I bend it a little bit so it's sticking up a little bit. And then I take a pair of tweezers, and if I'm really, really good, I can get a metal paper clip. And I'm not even in the right frame here. There I am, I'm over here. I can take a metal paper clip and I can make it float, even though metal is more dense than water. I can make it float if I do it right. And I didn't do it right. Come on, Jared, you can do it. I did it. And it's floating on top of the water. And I don't know if you can see it, but it's making little bitty dents all around it. It's like an indentation in the water. And that's really strange that it does that. Okay, so let me add something to it here. I'm going to take some pepper, put some pepper in there so you can see that floating. Then I'm going to try the soap experiment again that I did on my plates. Put a little bit of soap on my finger. What's the soap going to do to the water? Ooh, pepper. Oh, and it's sunk. Just like that. Boom. Went to the bottom. There's a connection between the soapy plates and the fact that that won't float anymore. All right. Let's move on. One more to go. Real quickly here. I'm making a huge mess. Next experiment. Graduated cylinder. Yeah, you can see it. All right, I'm gonna fill it up. Need water. This will work. Fill it up all the way to the tippy top. I keep going, and check that out. Let me slide it over towards you with my non-steady hands, I guess. All right, can you see that? I'm gonna move the screen. At the very top of the graduated cylinder, there's water that is going beyond the top of the cylinder. So if I put my hand, yeah, you can see it better if I put my hand behind it. See how it's domed up there at the top and it forms a big like bead at the top? That's strange that it can do that. I think if you had Mrs. Moon, you might have done an experiment. How many drops of water can you fit on a penny? See if I can make this taller. That's about as tall as it's going to go. So how many drops can fit on a penny? I think you've done that before. So we got to figure that one out. And then I'll explain all these things. All right, here we go. What you have going on here is a property of water. And the property of water we're concerned about is called cohesion and adhesion. Since water is a charged particle, it's got positive and negative charges to it. It's polar because it doesn't share its charges equally. And it tends to have these two properties called cohesion and adhesion. A lot of liquids have cohesion and adhesion. Some have more, some have less. Cohesion, you probably heard the word adhesion, like an adhesive. An adhesive is like glue, tape, something that sticks to something. So adhesion means like water will stick to something, stick to a different object. So for example, if I breathe on my glasses, the water sticks to it, so it adheres to it. So water is kind of sticky. If I squirt you with a squirt gun, it'll stick to your skin. So it has a sticky property to it. If it rains, it'll stick to the side of your windows on your house, so it sticks. So it's got sticky characteristics to it because it's got charge in it. So adhesion means to stick to other things. And also, it has cohesion, which means it'll stick to itself and form droplets and beads, so it coheses together. Cohesion, means like together, like, I don't know, let's say IU and Purdue tie in Big Ten basketball at the end of the season, so they would be called the co-champions, so they share the trophy, this cohesive. That would never happen, no, because Purdue would beat them. But cohesion means stick together. All right, so cohesion makes it make droplets and beads. When I do this experiment here, the water wants to stick to itself, and it also wants to stick to the screen. So it's got sticky properties to it. So when I flip it over, because it wants to stick to itself so much, and it wants to stick to the screen so much, it doesn't come out unless I tip it and kind of let the air flow in, then it comes out. So it's kind of sticky. Sticky. Now, if I put like honey in here, honey would stick even more together. If I put gasoline in there, gasoline has less cohesion and less adhesion, so it would probably not work. Okay, I didn't want to bring gasoline in, a little smelly. So water, pretty decent amount of cohesion and adhesion. It's difficult to keep them straight in your head what the two are. So adhesion means it adheres to other things. So this is kind of well, this is not kind of, it is adhesion here. I put water on this plate. When they don't have any water at all between them, they don't stick together. But when I put water on it, the water sticks to this plate. So it's not dripping off, it sticks to it to a certain degree. It's wet. If I put water on this plate, it sticks to that plate. I put them together to kind of make a water sandwich here. The water sticks to the plate on one side, sticks to the plate on the other side, so it adheres the plates together, and it sticks together, just like so. When I have the Petri dish floating here, the water sticks to itself so well, it forms something, it coheses, it sticks to itself, cohesion. It forms something called surface tension. Surface tension happens at the surface of a liquid. It's where the liquid wants to stick to itself, cohesion, and it forms this like little like force field almost at the top of it. Some liquids have more surface tension, some have less. If I had a container of mercury is the only metal that is liquid at room temperature. If I had a container of mercury, it's awesome, and I could throw all kinds of paper clips in there and they won't sink. I could even take a pool ball and sit it in there and it wouldn't sink either. So it has really high cohesion, and cohesion at the surface is called surface tension. Now, I added the soap, right? When I added the soap to the plates, they still stuck together, but not so well. They wanted to fall apart. They didn't want to stick really, really strongly. I mean, this is amazing how much this sticks together. So it's pretty sticky. As soon as I touched this with soap, paperclip fell to the bottom, so it didn't have a whole lot of cohesion anymore. Soap kind of kills the cohesion in materials. So It makes the water not want to form droplets. It doesn't form beads anymore, and it makes it flatten out, and it kills the surface tension of that, kills the surface tension in here. And if I put soapy water in this jar and flipped it upside down, do you think it would work? No, wouldn't allow it to have enough adhesion and cohesion. So here's another example of adhesion. I just thought of it. When you look at water, if I could hold this still, this would be a miracle. See how it makes like a dip in it, like a trough? That's called a meniscus. And the reason why it does that is because the water sticks to the edges of the graduated cylinder, sticks to the plastic and makes a dip. So that adheres. So when two different things stick together, that's adhesion. When two pieces of water stick together, same, that's cohesion. So it's difficult to keep them straight in your head. All right, so that is the demo part. Now I'm going to throw the vocab words up on the board. I wish I could get rid of that giant glare right there, or over there, but it's from the projector. Can't do much about that. So there we go, vocab words. Water properties. This is what we talked about today. Water has polarity. Water is made from positively charged hydrogen atoms and negatively charged oxygen atoms. Water's polarity makes it a material that can do what? It can dissolve other materials, easily. So water is called a solvent. A lot of times it's called a universal solvent. It's really good at dissolving things. Remember, if you mix polar, I'm going to put this on the side. Polar will mix with other polar materials evenly. So that's a good thing. We'll put a check mark. Non with non-polar. That's a good thing. They go together, no problem. But if you mix a polar with a non, doesn't work. It's like oil and water, they just don't mix. All right, because water has charge and it has polarity, it has some properties here. One of those is cohesion. Cohesion, co means together, is the attraction among molecules that are alike. All right, so water tends to cling to itself, so it wants to stick to itself, and it forms droplets. And if, like rain droplets, it forms drops, or you can say it forms beads. So when it rains, it forms beads. It goes down your window. It forms beads, and it goes down your shower curtain or your shower door. So droplets and beads, that's cohesion, sticking together. You can think of it down here. One molecule of water and another molecule of water go together. They cohere, they're cohesive, they stick together. All right? So stick together like peas and carrots. Adhesion. The attraction among particles that are what? Okay, this would be that are not alike. I don't know if I want to put different or not alike. We'll put not alike. Or not the same. It's when water sticks to another material. So water sticks to your glasses. That's two different things sticking together. Water sticks to you. When you get out of the pool, it sticks on to your skin for a while. It sticks to the window pane. It sticks to the roof of the hood of your car. So that's adhesion. Two different things sticking together. Examples? Oh, I just listed examples here. Water on bathroom mirror after you take a shower, that's adhesion, two different things sticking together. Water sticks to you. So if I dump a bucket of water on your head, sorry about that, my video cut out. So we were saying adhesion is when water sticks to other things, sticks to your bathroom mirror. With my marker. Marker's pooping out on me. Sticks to your bathroom mirror when you take a shower. It'll stick to you if I dump a bucket of water on you, so it sticks to other things. So this is adhesion here. So water sticks to other stuff. That's adhesion. And then last, I don't think I have a blank on that, but surface tension. Surface tension is when you have cohesion at the surface of a liquid. It tends to make it stick together. So for example, surface tension here, these little water molecules are sticking together. They want to stick to each other. They form like a little shield, like a little force field, and it allows things to float on top of it, kind of like the paper clip I showed you. Or, I don't know if you have a pool, but you get these little bugs on top. I call them water spiders or water striders, and they just sit on top of the water and they make little dents in the water. So you can destroy kind of surface tension by adding like soap. And you saw that with those plates, they wouldn't stick together anymore. And when I put soap in the Petri dish, the paper clip sank. So I usually have a student every year ask me, so if you had a water bug in a Petri dish or in a cup of water and he was floating on top and you squirt soap in there, would he sink to the bottom? And the answer is yes. So you could torture and drown little water bugs if you wanted to. All right, that takes care of the new material. I will send you a Google form. It'll be attached to the assignment. It'll have a couple of questions for you to answer. And that'll be everything we need to do for Monday. All right.